So today we are going to be doing a problem like this. Find the exact values of each of the 6 trigonometric functions of an angle theta if point 4, -3 is the point on its terminal side in standard position. So what does that mean? I drew a little coordinate plane here. So if 4, -3 is the point right here, okay? So terminal side in standard position, that means that your initial side is here, just think of it like an angle, and your terminal side, oh, that's not a straight line, let's pretend that that's a straight line, okay, is here, okay? So this is your angle theta that's right in here, that's what that means, okay? So what you can do is, if I know that this is 0.43, I can just make a line here, and I can make this into a right triangle, okay? And if this coordinate is 4, 3, that means this is 4 and this is -3, right? So this here is 4. This length is 3, okay? Lengths are never negative, but since you're going down in this direction, if you want to put the little negative there just to remind you that it's going in the negative, okay? Because that's going to help you determine which functions are positive and negative in this quadrant. I wrote this up here to remind you. Remember, I put all students take calculus. That's a little helpful trick to remember that everything's positive in this quadrant, only sine is positive in this quadrant, only tangent is positive in here, and only cosine is positive here. All right, so I want to find the 6 trig functions, right, of this angle theta if this is a point on the terminal side, okay? So, well, I have 2 of my legs, but I need to find my hypotenuse, which you can use the distance formula from 0, 0 to 4, -3, or you can use the Pythagorean theorem, which, you know, they're derived from the same place. So if I use Pythagorean theorem, which I feel like most of you would go with that, I have 3 squared plus 4 squared equals hypotenuse squared, right? So I get 9 plus 16 equals c squared. 25 equals c squared. So my hypotenuse is 5, right? Which, if you notice, this is your 3, 4, 5 special triangle, right? One of your Pythagorean triples. All right, so then I could just figure out, what is my sine of theta, right? If I'm standing on this angle here, my sine is opposite over hypotenuse. But be careful, in this quadrant, your sine, because your y is negative, your sine is negative. So it's going to be a -3/5. My cosine is adjacent over hypotenuse. Those are both positive, okay? And just so you know, your x is positive here, your y is negative here. Your hypotenuse or your radius is always going to be a positive value, okay? Lengths are always positive, but depending on the quadrant will affect your positive or negative, okay? But the radius is always going to be considered positive, okay? And then my tangent is opposite over adjacent, so I have -3/4. And then just match them up. Cosecant. If your sine is negative, one second, Claudia, sorry, my daughter's talking to me. Just give me 1 second, okay? Okay, just wait. If my sine is negative, then my cosecant is also negative, but it's the reciprocal, so it's -5/3, okay? My secant will be the reciprocal of cosine, so it's 5/4. And then my cotangent, if this is -3/4, my cotangent is -4/3. All right? So I'm going to be giving you a couple of, practice problems like this, where I'll be giving you the points, and they'll be in different quadrants, and you'll have to determine the 6 trig functions, and you'll have to find the missing legs. So you could use your Pythagorean theorem, or you can use the distance formula, okay, which you can get. Obviously, you can get the distance formula if you need. All right, let me know if you have any questions. Have a good day.